today I will be presenting to you multiplicative inverse and modular arithmetic. So what is multiplicative inverse in modulo? The multiplicative inverse of a number a in modular arithmetic is another number b such that when you multiply a by b, so the result is congruent to 1. So when we multiply a to b and divide it by m, it should be congruent to 1 or should have the remainder 1. So the key points of inverse multiplicative in modulo is the existence. So it only exists if both a and b are co-prime, and the use of this is in cryptography, solving linear congruence, in error correction, and as well as network security. So let us head to the first problem. So we have here a problem in cryptography. Alice is developing a secure communication system that uses a key of 7 modulo 26. To ensure she can decode her messages, she needs to find the multiplicative inverse of 7 modulo 26. So what is the inverse? So we have here 7 congruent to 1 modulo 26. Modulo 26. So we're finding here the x. So in order to find x, the value of x should be less than 26. So let's input this. So the first number to multiply to 7 is 10. 7 times 10 is equals to 70. And we will divide 70 by 26. So 70 divided by 26 is 2. 2 times 26 is equals to 52. And we will minus it. So it equals to 18. Which is, we could conclude that 10 is not a inverse of 7 modulo 26 because the remainder should be 1. So 7 at 10 is not a inverse of 7 modulo 26 because it is not congruent to 1. So the next number is 11. 7 times 11 is equals to 77. And we will divide 77 by 26. And here again, 7 divided by 26. We still have 2, and 2 times 26 is 52. And the remainder is not equals to 1. So it is not congruent to 1. It is not the inverse of 7 over 26. And now here, 12. 12 times 72. 7 times 12, is 84. So 84 divided by 26. Is 3. So 3 times 26 is 78. And still, we will not get a remainder of 1. So let's move on. And let's conclude that 7 times 12 is not congruent to 1. So it is not a inverse of 7 modulo 26. And we have here 7 times 13, which is 91. And let's divide 91 by 26. And so 91 divided by 26 is equals to 3. And 3 times 26 is 78. And still, 91 minus 78 is still equals to 13. So, not 1. So, we could conclude that the number 13, 7 times 13 is not congruent to 1. So, number 13 is not the multiplicative inverse of 7 modulo 26. So next we have here 14, which is 7 times 14, which is 98. And let's divide 98 by 26. So 98 divided by 26 is equals to 3. Still 3. So 3 times 26 is equals to 78. And when we minus this, we have 20. So, still not equal to the remainder of 1. So, we could conclude that 14 is not a multiplicative inverse of 7 modulo 26. So, still, we have here the number 15. So, 7 times 15 is equals to 105. And 105 divided by 26, we have 4. And 4 times 26 is 104. And when we minus 105 to 104, we get the remainder 1. So now we can conclude that 17 times 15 is congruent to 1 modulo 26. So, the multiplicative inverse of 7 modulo 26, we could now conclude that x is equals to 15. Because when we multiply 7 to 15, we will get 104, and when we divide 105, we get 105, and when we divide 105 by 26, we get the 104 value, and when we minus 105 to 104, we get the remainder 1. So, the multiplicative inverse of 7 modulo 26 is equals to 50. So, we have here problem number 2. So, problem number 2 is about game score calculation. So, in a competitive game, a player scores 9 points. So, to determine the multiplier, they need to reduce their score to exactly 1 point under modulo 11. So, what is the multiplicative inverse of 9 modulo 11? So, we have here 9 modulo 11. So what the problem is asking here is you need to find the value of x. So with this done, we try 9 times 1. So instead of multiplying 9 by 1, we should multiply 9 by a bigger value. So let's start 9 times 3, and 4, and 5. So, we have here, the first number that we will multiply to 9 is 3. So, 9 times 3 is equals to 27. And let's divide 27 by 11, and we'll have 2. And we'll multiply 2 times 11 is equals to 22. And we'll have the let's subtract 27 by 22, and we'll have 5, which is not equal to the remainder 1. So the next number we multiply to 9 is 4, and 9 times 4 is equals to 36. And we will divide 36 by 11, and we'll have 3. And 3 times 11 is 33. And still, when we minus the 36 by 33, we have the number, the remainder 3, which is not equal to 1. So it is still not the inverse of 9 modulo 11. So let's multiply 9 by 5, the next number. So 9 times 5 is equals to 45. And we will divide 45 by 11. And we will have the value of 4. And when we multiply 4 by 11, we have 44. And when we minus 45 to 44, we will have the remainder 1. So we could conclude that 9 times 5 is congruent to 1 modulo 11. So here, the value of x is equals to 5. So the inverse, the multiplicative inverse of 9 modulo 11 is 5. So for problem number 3, we have here resource allocation. So a factory produces 12 units of a product and needs to distribute them evenly among 5 teams. To calculate how many items each team should receive to leave exactly one item unallocated, what is the multiplicative inverse of 2, the number of teams, modulo 5? So we have here a problem of 2, the value of x, 1 modulo 5. So let's find the value of x, and so the first number we will multiply is 1. So 2 times 1 is equals to 2 divided by 5. So still we will not get the remainder 1. And let's proceed to the other number because 1 is not, 2 times 1 is not congruent to 1 modulo 5. So 2 times 2, 4 divided by 5. Still, we will not get the remainder 1. So it is not congruent. 2 times 2 is not congruent to 1 modulo 5. So the next number we multiply is 3. So 2 times 3 is 6. And 6 divided by 5 is equals to 1. So 1 times 5 is equals to 5. And 6 minus 5 is equals to 1. 6 minus 5 is 1. So the remainder that we have is now number 1, which will conclude that 2 times 3 is congruent to 1 modulo 5, and x here is equals to 3, and we could now conclude that the multiplicative inverse of 2 modulo 5 is 3. So we have here problem number 4. So for problem number 4, we have here financial transactions. So John has a debt of $4 and wants to find out how much he needs to multiply by to effectively settle his debt to $1 under modulo 7. So we're finding here the multiplicative inverse of 4 modulo 7. So the first number we'll multiply by 4 is 1. So 4 times 1 is equals to 4. And 4 divided by 2, by 7, still we will not get the remainder 1. The next number that we will multiply is 2. So 4 times 2 is equals to 8. And 8 divided by 7 is 1. And 1 times 7 is 7. And 8 minus 7 is equals to the remainder of 1. So we can now conclude that the number 2 is the multiplicative inverse of 4 modulo 7. So here, x is equals to 2, and 2 is the multiplicative inverse of 4 modulo 7. So for problem number 5, we have digital signatures. So in a digital signature scheme, a user needs to verify their signature using a second key of 5 modulo 13. So to do this, they must find the multiplicative inverse of 5 modulo 13. So what is the inverse? So we're finding here the x, which when multiplied by 5, you will have, it will be congruent to 1 modulo 13. So instead of starting at number 1, we'll start on a bigger number. When we multiply a bigger number by 5, it will exceed the number 13. So we'll start at number 5. So 5 times 5 is equals to 25, and 25 divided by 13 still have 1 and 13, and we will still not get the remainder 1. So the number 5 is not congruent, is not the multiplicative inverse. So 5 times 5 is not congruent to 1 over 13. So the next number we have is 6. So 5 times 6 is equals to 5 times 6, so 5 times 6 is equals to 30. And 30 divided by 13 is equals to 2. So 2 times 13 is 26. So 30 minus 26, we have the remainder 4. So still, the number 6 is not the multiplicative inverse of 5 modulo 13. So 5 times 6 is not congruent to 1 modulo 13. So the next number we have is 7. So 5 times 7 is equals to 35. So 35 divided by 13 is 2. So 2 times 13 is 26. And still, the remainder of this is not 1. So the number 7 is not the multiplicative inverse of 5 modulo 13 because 5 times 7 is not congruent to 1 modulo 13. So the next number we have is 8. So 5 times 8 is equals to 40. And 40 divided by 13 is equals to 3. And 3 times 13, we have 39. And when 40 is subtracted by 39, we have the value 1, which is the remainder of 40 divided by 13. So now we have the remainder of 1, and we now conclude that the number 8 is the multiplicative inverse of 5 modulo 13 because 5 times 8 when we times it is equals to 40 and divide by 13, we'll have the remainder 1. So x is equals to 8. So for problem number 6, we have here inventory management. So a store has 15 items and it wants to arrange in groups of 4. So to ensure they can achieve a configuration where exactly one item remains ungrouped, what is the multiplicative inverse of 4 modulo 15? So instead of starting at number 1, we'll start at a number that when multiplied by 4, it exceeds the number 15. So what number is that? So when 4 times 2 is equals to 8, and still it does not exceed 15, and when 4 times 3 is equals to 12, and still does not exceed the number 15, and we have here 4 times 4, which exceeds the number 15. So we are finding here the x, and we have here 4 times 4, and when 4 times 4, we have 16, and when 16 is divided by 15, we have 1, and 1 times 15, 16 minus 15 is 1. So when 16 is divided by 15, we will have the remainder 1, which concludes that the number 4, the x that we are finding is equals to 4 because when 4 times 4 is congruent to 1 modulo 15. So the multiplicative inverse of 4 modulo 15 is the number 4. So we have here problem number 7. So for problem number 7, we have recipe adjustments. So a chef is modifying a recipe that requires 6 tablespoons of sugar. To find out how many tablespoons they should use, considering a target of sweetness to 1 tablespoon under modulo 8, what is the multiplicative inverse of 6 modulo 8? So here 6 modulo 1 modulo 8. As you can see, as I explained earlier, A M should be a co-prime in order for it to have a multiplicative inverse. So as you can see here, both A and M are even numbers. So X, whatever number we multiply to 6, we will not have the remainder and any number you multiply by 6 and divided by 8, we will not have the remainder 1. So we could conclude that 6 modulo 8 is the multiplicative inverse of 6 modulo 8 is none. So we don't have a multiplicative inverse because A and M should be co-prime. So next we have problem number 8. So for problem number 8, we have network connections. So in a computer network, each computer can connect 3 other computers. So to find the connection needed to reach one specific computer under modulo 10, we need to find the multiplicative inverse of 3 modulo 10. So we are finding here 3, the value of x should be, when multiplied, given to 1 modulo 10. So instead of starting at 1, we'll start with a number that will multiply by 3. The product of a number and 3, it should exceed the number 10. So 3 times 3 is equal to 9, so it does not exceed the number 10. So we'll start at number 4. So 3 times 4 is equal to 12, and when 12 is divided by 10, we have 1, and 1 times 10, we have 10, and 12 minus 10, we have the number 2, which is the remainder of 12 divided by 10, and 2 is not number 1, because we are finding the remainder should be number 1. So, the number 4, 3 times 4, is not congruent to 1, modulo 10. So the next number we will multiply is number 5. So 3 times 5 is equals to 15. So when 15 is divided by 10, we have 1, and 1 times 10, we have 10, and when subtracted, we'll have the remainder 5. So 15 divided by 10, we have the remainder 5. So we conclude that 3 times 5 is not congruent to 1 modulo 10. So still, we should proceed to another number, which is number 6. So 3 times 6 is equal to 18, and when 18 is divided by 10, still 1, and 10. 1 times 10 is equal to 10, minus 8, and we have the remainder 8. So 18 divided by 10 still have a different remainder, which is 8. So it should be 1. So we conclude that 3 times 6 is not congruent to 1. So it is not the multiplicative inverse of 3 modulo 10. So let's proceed to another number. Number 7. So 3 times 7 is equal to 21. And 21 divided by 10 is equals to 2. And 2 times 10 is equals to 20. And when subtracted, 21 minus 20, we have the remainder 1. So 21 divided by 10, we'll have the remainder 1. So we conclude that 3 times 7 is congruent to 1 modulo 10. So we conclude that the multiplicative inverse of 3 modulo 10 is equals to 7. So for the second to the last problem, problem number 9. So problem number 9 is all about music notes. So a musician is working with a musical scale represented modulo 12. So if we play a note represented by 7 and want to find the inverse note to return to the tonic, the root note, what is the multiplicative inverse of 7 modulo 12? So instead of starting to 1, we should start at a number when multiplied by 7, it is the number 2. So when 7 times 2, so we have here, we're finding here the value of x. So that when multiplied by 7, it is congruent to 1 modulo 12. So as you can see, we will not start at 1 because 7 times 1 does not exceed the number 12. And 7 times 2, we have 14. And when 14 divided by 12, we have 1. And 1 times 12 is 12. And we will have the remainder 2. So 14. So we will conclude that 2 is not congruent to 1 modulo 12. So instead of starting 3 up to 4, we will skip that numbers and we will start at 5. So 7 times 5, 1 is equal to modulo 12. So we will times 7 to 5. So 7 times 5 is 35. And when divided by 12, 0. So 35 divided by 12 is equals to 2. So 2 times 12 is equals to 24. So still, we will not get the remainder 1. So we conclude that 5 is not multiplicative inverse of 7 modulo 12. So we'll try another number. So we will try number 6. So 7 times 6 is equals to 42. So 42 divided by 12, we will have 3. So 3 times 12, 36, and still, we will not get the remainder 1. So we conclude that 6 is not the multiplicative inverse of 7 modulo 12. So let's proceed to another number, which is 7. So 7 times 7 is equals to 49. So 49 divided by 12, we will have 4. So 4 times 12, we have 48. And when we minus 49 by 48, we will have 1. So 49 divided by 12, we will have the remainder 1. So we conclude that 7 times 7 is congruent to 1 modulo 12. So x here, we conclude that the multiplicative inverse of 7 modulo 12 is equals to 7. So for the last problem number 10. So for problem number 10, we have here project scheduling. A project manager has 9 tasks to assign to 5 team members. To find the optimal distribution that allows exactly 1 task to remain unassigned, what is the multiplicative inverse of 4 modulo 5? So you're finding here 4, the value of x, modulo 5. So instead of starting at 1, we should start on a number that will multiply by 4 exceeds the number 5. So we'll start at the number 2. So 4 times 2 is equals to 8. And 8 divided by 5, we have 1. 1 times 5 is 5. When we minus it, we have 3. So 8 divided by 5, we will have the remainder 3. And we will conclude that 4 and times 2 is not congruent to 1 modulo 5. So we'll proceed to another number, which is 3. So 4 times 3, we have 12. So 4 times 3, we have 12. And 12 divided by 5, we have 2. And 2 times 5, we have 10. When subtracted, we have 2. So 12 divided by 5, we will have the remainder 2. So instead of 1, we have the remainder 2. So we could conclude that 4 times 3 is not congruent to 1 modulo 5. So let's proceed to another number, and let's find the multiplicative inverse of 4 modulo 5. So the next number we So 4 times 4 is equals to 16. So 16 divided by 5, we have 3. And 3 times 5, we have 15. And when we subtract it, we have the value 1. So we conclude that 16 divided by 5 has the remainder number 1. So we conclude now that 4 times 4 is congruent to 1 modulo 5, which the multiplicative inverse of 4 modulo 5 is equals to 4. So, a quick recap. So we have A, the value of B, congruent to 1, modulo, and the value of the modulo, which is M. So, A and M should become prime. And in finding B, A and the product of A and B divided by M, so A and B divided by M. So when we divide the product of A and B divided by M, we should have the remainder 1. So to find the multiplicative inverse, B should the product of A and B, we're finding this. So the product of A and B divided by M should equal to 1, so that we could declare the multiplicative inverse is the value of what is being in here. So that's all. Thank you guys, and good night.